Newer.
Yeah.
How's
We haven't used
everybody
this before.
doing? This is very new to me.
Yeah. This is not Crowdcast.
It's not.
Okay.
It's
Yeah.
podcast.
Okay. I don't think we have anyone watching us right now, but we'll start anyway.
Fine. It's fine. It's silly goofy.
We'll just talk to each other, I guess.
That's we build the sense of community.
Yeah.
Okay.
Okay, so I'm Juliana and
I'm Elias.
okay, there you go. And then we're doing the first half of AP Stats using the Fiveable practice website. So we'll be showing you some Fiveable questions.
We can walk through anything. We can share any info, but and we still have, I feel like I should wait to like load up a quiz or at least start it here.
Any unit preference?
Wait. Maybe like 3. Maybe.
Okay.
Maybe.
I really wish these units had names attached because you think I'm gonna remember which is which just from the number.
Okay, that one's collecting data.
Okay. Exploring 2 variable data.
I'm guessing this is going to be, exploring 1.
Yeah. Look at that. Nice and predictable.
Ooh.
Yeah.
I think this is a good one to start off on. I think it's a good like fundamental unit.
Yeah.
Unit. Something like that. Bonk. Oh wow. Oh, okay. I see what's happening.
Okay.
What's going on here?
Let's see.
Maybe hello, we can person from YouTube. Very excited to have you here today.
Hello.
Okay.
We're doing probability questions for AP Stats.
Yes.
So how long has it been since you've done AP Stats?
Me?
Yes.
It was my sophomore year of high school, so I guess 3 years ago now.
Yeah, same. Let's see how much I remember.
What? I definitely know everything and will not be occasionally checking Google to make sure I don't just straight up lie to some people. You know. We're getting more people.
Oh. Yay.
Yay.
Go ahead with the first question.
All right. So, which of the following conditions is necessary for using the binomial distribution to model a random event?
Do you have a unicorn cursor?
No, it's not a unicorn. It's like a colorful blob.
Oh, okay. It looked like a unicorn in my poor camera quality.
I could probably make it a unicorn.
That would be fun.
Here,
and by the way, if anyone is using the Fiveable practice questions, if you see something like blue and purple, you can click on that term and get it explained to you.
Like this?
Yeah, like that. I did not realize that until Monday, and I was like, wow.
Yeah, no, it's a nice little feature. It's very helpful.
Yeah.
Are we supposed to answer, or I assume
we're supposed to answer.
Oh.
Unless someone wants to answer in the chat.
I would love to hear some theories in the chat.
Yeah, what even is binomial distribution?
You don't know what a binomial? Oh my gosh. Okay.
Explain for the class.
Here. I'm pulling it up. I'm trying to find a good image.
Okay. Will it involve a tree?
What?
Will your image involve a tree? Because that's the one they always showed us in class.
Oh, it can.
But if you have any questions or any answers to any of these questions, then feel free to put them in the chat.
Yes.
We try to read them.
So, just for context for anyone watching, definition here, and summarizing what it says over there, binomial distribution is basically, it's a probability distribution that models the number of good outcomes, as in what is being looked for, the success, in a number of independent trials. which each trial has the same probability of said success occurring. Success here doesn't necessarily mean something that's like succeeding.
Good. Like, it could be you have cancer, which is not necessarily a success.
Also does not have a consistent probability.
Maybe you can be struck by lightning.
Being struck by lightning isn't going to give you cancer.
They're not related. Maybe lightning has a more consistent probability.
Height.
I don't know, being hit by a car.
Why are these so morbid?
Because you just said success that isn't success.
Oh, okay. I said it didn't have to be success.
Well, yeah, basically whatever desired trait we're looking for.
Here. I'm trying to find a good example that doesn't just make it more confusing. Here, I'll just take this.
Yes. I mean, I remember in class we did one about basketball. So, like, what's the probability that you'll get 6 shots if you have like a 50% chance of getting each shot or something like that?
Yeah, let's see if that comes up because I think I did the same one. Well, oh look, this one works.
Ooh, fancy! Look at that.
Look at that. You even get multiple colors. So
wow.
the probability of getting heads, which in this case 50%, 0.5, whatever number you want to give me, the number of heads from 20 tosses. And as you can see, I don't know if someone has the word for this, but it makes a nice little specific kind of curve.
Yeah. Very important curve.
A very important one. If someone wants to drop that in the comment or chat or whatever, like, you know. But has this specific curve. And the binomial probability is basically just a way to reflect this, showing that when you have this consistent success rate, how it will be graphed out.
Basically, this curve is showing you, assuming you're like looking for a certain number of heads, it's showing you the probability of that happening out of 1. So like 0.8 out of 1 basically means 18 times out of 100, you'll see this number of heads.
Yes. Perfect. Thank you. Great point. I didn't even think to bring that up. So going back to this tab.
To the question.
Which of the following conditions is necessary for using the binomial distribution to model a random event?
Well, I'm going to say it's not varying probability of success, which would make binomial distribution that's impossible.
Yes.
So that's the wrong answer.
I can say the same about the variable number of trials in the in the definition. Whoa.
It's the Bernoulli man.
Wow. So we have it down to our last two. And dependent and binary is certainly a way to put it. Do you
I don't think it can be dependent because we're saying that the probability of success is the same for each trial. So if it's dependent, then it's automatically different probabilities involved.
Correct. And in the case of having a success or a failure, there's no semi-success. You either have it or you don't, which means you are working within a binary system.
You can't have like a not heads and not tails, assuming that the coin has no edge, I guess.
Yeah, you have a perfectly flat coin.
Two-dimensional coin.
Oh man, I feel like that would break some sort of physics.
Probably.
Ooh.
Okay, you can either make a basket or you can miss a basket in basketball, and you can't like do neither.
I don't know, you can get the ball stuck.
Well, that's still missing the basket.
What if it gets in the basket but then gets stuck?
And you made the basket and then someone pokes it out for you.
You know what? Fair enough. All right. A random variable x has a mean of 18. If you transform x by dividing each value by a constant of 2, what is the mean of the transformed variable y? Transform x.
Any ideas, anyone? Again, feel free to put any questions inside of the chat.
You know, it's been a minute since I took AP Stats, but I'm looking this and I'm somewhat confused, to be completely honest.
I think the best way to do stuff like this, I don't know why to say random variable. I think they mean more like a set of numbers.
Okay.
I feel like random variable is a terrible way to put this, but basically if you had a set of numbers that's mean is 18, and then you transform that set by dividing each value by 2, what's going to be the mean of the new set? And then the best way to do this is literally just to make a set of 2 or 3 numbers that do have a mean of 18 and then manually do the transformation. Like divide all of them by 2 and find the new mean.
Okay, that you changing random variable to set makes so much more sense because I was like, where are we getting the y from? Okay, that makes a lot more sense. So
yeah, this was not a very well worded question because variables can typically take on one value at a time, so they can't really have a mean. Poorly worded.
One variable with set, please.
Yeah.
Please. There we go.
And yes, if you have any feedback or catch a mistake, you can tell us.
Yes, and it does get looked at.
And we change them.
Indeed. So, looking at this, if we're dividing every value by 2, I can almost guarantee it's not
going to be higher.
Going to be higher or
the same.
If you're making it smaller by dividing it, and it's asking about the mean, not the standard deviation, it's talking about the mean, then it's probably not going to remain the same number.
And just as a reminder, the mean is if you add everything together and then divide by the number of items within the set.
It's the purest form of average.
Yeah.
We love means, except
the middle, sort of.
Middle. So with that leaves us with either mean of y is 2 or the mean of y is 9. Last time I checked, theoretically, I feel like 2 might be a little bit too low.
Probably.
So, bada bing, bada boom. Yes, the faster route was just going 18 divided by 2, but then we wouldn't have been able to explain it to you guys as well, right? We're here for a good time, not a concise time.
Although on the exam, if you find a faster way to do things, please take it because you are timed. You are there for a concise time.
Please divide by 2 in that case.
Oh, and just as an aside, if it was a standard deviation, then it should change differently, right?
Yes. Let me verify before I lie.
And standard deviation has a pretty complicated formula that even I can't really remember off the bat. It's something like you square both of them and you subtract, and then you take the square root or something, but it's really complicated, so just use your calculator.
It really is. So what will happen is if you are doubling every term, the distance between each term and the mean doubles. But the distance between each term also doubles and the standard deviation increases. In this case, with the question, the opposite will be true and the standard deviation will still decrease. Hello, the Bleach Boy.
Hello.
How are you tonight? Hope all is well. We're just working through some questions. Ooh, I hear a little tip-tap. So, what are
we looking at?
The geometric random variable, which is used to model.
Oh, that's a spoiler, isn't it?
Oh, I'm sorry. I thought we were going the concise route. The concise route, We're going to pretend like my foot did not get caught on my chair right now.
You're okay.
Yeah, no, well,
You're alive.
I'm alive. We'll debate if I'm okay right now, considering this. Oh, awesome, awesome. Since you are asking in the chat, is there any specific topic or unit you would like us to go over? Right now, we're really flexible. You're our most active member at the moment.
You're a captive audience.
Very attentive, captive, whatever word you want to use. Ooh, okay. This unit, perfect. If there's any particular topics you want to go over, let us know. We can switch to a specific topic as well. For now, we're happy to just keep running through this. So, what is a geometric random variable used to model? Since it's spoilers, I suppose I won't look at the little option we give you to see the term. So how would you start breaking down this question?
I think this is mostly a definition question, so I think you need to know what a geometric random variable means.
That's true.
Unfortunately.
Do you know what the features are? Because one of the first that comes to mind is it's used when someone is modeling a series of experiments that have two outcomes, the success or the failure. And if I remember correctly, I do remember geometric having something to do perhaps with the number of times something is done before a success.
Sounds about right to me, honestly.
Fair enough. So using that information without me hitting this, I suppose, what are we looking for out of these options? Are there any that we can maybe cut out? Because one stands out to me, and it's this one. Success in stats is literally just the thing you're trying to get. If you're trying to get what is considered a failure, then you would just say that that is the success.
Yeah, you're never looking for a failure in stats.
Even if the success is something that seems like a failure, it's still a success in terms of stats. Any other that stand out to you to cut down? Ooh, Bleach Boy says I should be the first option, top left. Let's hit it. Let's see. Awesome. Perfect.
Yay.
Yeah. Awesome. Exactly. So geometric random variables are used to model the number of trials needed to achieve the first success in a sequence of just independent trials. And it's made up of separate components, number of successes, the number or a fixed number of trials, independent trials, all the trials, and the number of trials needed to get to the first failure are all used or are used instead to describe the purpose of a binomial random variable, which does have a somewhat different. It's always something that I struggled with in AP stats was trying to just differentiate geometric versus binomial. But we went over the binomial already, so I think it is time for the next question. Oh, okay.
Yeah, but just to repeat that, binomial is the probability of a certain number of successes, and geometric is the probability of this trial being the first success. So the equation for a geometric random variable is you're going to multiply the probability of success times the probability of failure times how many to the power of how many numbers of trials. For example, if you want the third trial to be the success, then you have the probability of succeeding on the third trial and multiply that by the probability of failing on the first trial and on the second trial. Since the probability should be the same for succeeding for all trials, it would look like, let me see if I can pull it up. P times 1 minus p times to the x to the negative 1 power. Let me quickly share my screen because that's a little hard to visualize. So it's going to be this equation right here.
Is it not coming up? Here, let me try stop sharing and then see if
Yeah, maybe you should stop sharing.
There we go. It brought up a button to just like let me hit it, and then nothing happened. So I was like, oh.
Okay, let me try that again. Maybe it glitches if two people try it at the same time.
Weird. No, it's still. You can add them.
Oh no, never mind. I found it.
Oh, okay.
There we go. Ta-da. Here. It should be the one at the top. I don't know if you can see me circling it. Can you?
I can, but I'm
okay,
also
feedback. Okay, hopefully you can. So this P is the likelihood of success, and then this 1 minus P is the likelihood of failure. So if you're on your third try, you want 2 failures, 3 minus 1 equals 2, and 1 success. And the probability of all of that happening is the probability when you multiply out all of the individual probabilities. As you probably learned earlier, the AND function, or probability of something and something else happening, is found by multiplying the two original probabilities together. Yep. Okay, let me stop sharing. Okay. You can probably share your screen now.
I probably can.
I think you can.
Sure. Why can't I positively share my screen? Is it sharing?
Because of this terrible, terrible device.
There we go.
Okay, we did it.
So, taking that into account, how can we break this down?
Let me zoom in because like.
Oh, here.
Wow, look at that.
There we go.
Nice.
It's a funny number. Does that make it easier?
Yeah, that works perfectly fine.
So the first thing that stands out to me is the number of trials. And the number of trials we're wanting to look for, or we were wanting the equation to have one less than that, correct?
Yeah, because you need one success and everything else has to be failures.
Perfect. So we're probably going to scratch out these two left ones. So how do we know whether or not to use 0.7 or 0.3?
Well, I think one of them is 0.7 and 0.7, and the other is 0.7
and
0.3.
That one's a little bit more blatant.
Yeah, perhaps this would have been a better question if they had flipped 0.3 and 0.7, which is what your teacher is more likely to do. But remember, the one with the exponent is going to be the failures, because you're going to have multiple failures, but you can only have one success.
Perfect. We feeling all good about this one? Think so. Us and our 3 viewers.
We're very popular.
Oh. Which inequality represents the 10% condition with a random sample size of size lowercase n from a population of size capital N? Ooh, 10%.
All of these n's.
Too hard to verbally say. So with the 10% condition, the 10% rule is basically assuming independence between trials. And what that means is if the sample size is less than 10% of the total population, you can assume in that case that it is independent in that case. So
yeah, keep going.
Sorry. So with that in mind, we're going to assume the question states, so we are assuming that the population is being represented by capital N. And we're looking for the random sample of size n. If we're looking for size n to be 10% of the population size or smaller, how would that be numerically represented? I personally, this one immediately crossed off. We're not 10%ing. And this one, we're also not 10%ing. This is a 10, not a 10%. So...
And you have to see here also that the population definitely has to be bigger than the sample size. So capital N should be on the bigger side of the inequality.
Yes, yes.
Because you can't sample more people than exist.
Correct. So that would mean, I'm hoping I'm hitting the right one. My brain's not far. There we go. Yep. There we go. Yes. Good point that this explanation is bringing up. This is for binomial models. This is for when independence is most important.
I mean, all models will look at independence,
Yes.
but yeah, on the free responses, I do remember that you have to put independence in this condition somewhere on your paper to get a point, or else they can't like prove that the following like calculator stuff actually works out.
Which is very silly in my opinion, because you wouldn't give someone a 7 like question set if it didn't work. Like,
I think they just want you to show like the principal statistics that you need it to be independent or something.
agreed. Wonderful. Next question. Ooh.
Wow,
Okay.
that's a lot of highlighted terms.
Indeed. Okay. I'm going to assume that means set. A random set X has a mean of 5 and a standard deviation of 3. If you transform X by multiplying each value by a constant of 6, what is the mean and standard deviation of the transformed set Y? They really need to use the word set, not variable. It throws me off so bad.
Yeah. Wait, what happens when you click on variable? What do they give the description as?
Represents the outcome of a random phenomenon.
Okay, I see.
I get why they're using it. I think set would be a little bit more concise. So we have a
They
starting.
do tend to use a random variable on the AP exam, I think, though. So they might just be modeling this.
That's fair. That's a good point. I forgot about that, even if I think it's a little silly.
It is a little silly. But you can replace random variable with like a set of numbers in your head because it basically turns out to be the same thing.
Yeah. So with this, we know we're transforming everything. Everything's being transformed by a constant of 6. I think the thing that's a little bit easier to remember is that mean is always going to be impacted by a constant because the mean is the average of a bunch of different numbers. If all of those numbers are being multiplied by 6, one could perhaps assume, dare I say, that the mean would also be impacted by that constant of 6. So we can cross out mean of -1 and mean of 5. The second part is where I find more people get a little tripped up, and I've gotten tripped up myself in the past by this. Standard deviation is kind of the space between things. Something that is more spread out in terms of data is going to have a greater standard deviation than something that is very compressed data-wise. However, when you multiply all values within the set by 6, you're also increasing the distance between each of those points. Ratio-wise, distance is the same, but in terms of the actual numerical value and the linear distance between the two, that is also going to be increasing with your constant of 6, which means your standard deviation is not also going to be 3. Both things will be increasing.
I will add, though, that if you're adding or subtracting a constant
Yes.
number, the mean will change by adding or subtracting that number, but the standard deviation will not. Literally picking up the whole set and moving all pieces over a certain distance, which doesn't change the individual distance between any points.
Yes, absolutely. Thank you for making that up. Yeah, if you're just adding, that space between is going to stay the same. If you're multiplying, you're going to be changing the amount of distance. Perfect. Also, the Bleach Boy, you're killing it right now. I've been watching you answering these on the right. I have nothing to add because you're getting them all correct. Oh.
Ooh. When analyzing data.
Oh, when analyzing data, why is it important to identify and control for bias? My favorite answer is you shouldn't control for bias. You should just let the bias continue and watch them mess up their data.
I am biased, and I'll keep it that way.
We're all biased. Bias is part of human nature. Ooh. Perfect. So, when analyzing data, why is it important to identify and control for bias? introducing systematic variations into the data is a really funny answer because you're not trying to influence variation other than what's the natural variation that occurs. You're
That
messing
that basically says that you want to fake your data.
I mean, who says I don't? Maybe
I
that's how
guess
I get through
maybe
my
you do.
labs. I don't have a lab. I don't take any lab classes.
Yeah, I have a lab, and sometimes we do make up data points if we forgot to write them down.
Did I do that during AP Chem? We'll find out. To eliminate all sources of error in the data, every single one can be stopped just by removing bias. You spill some beans into your cup of marbles, not gonna impact anything anymore because you removed the bias.
You're not looking at it anymore, so those beans don't exist.
Exactly. Perfect. Infallible law. Yeah, no. Just because you don't have bias does not mean you don't have error. Error can come from other ways, including your math is silly. Your process is silly. Someone poured beans into your marbles. You used a non-number 2 pencil on the AP exam and other things. So that leaves these two, these corner ones. Corner.
I mean, they're all corners.
Corners. Don't be rude. Don't be rude. None of that.
Okay, moving on.
The top right and the bottom left. There we go. So both of these are things you want. You want accurate conclusions about your data, and you want your variations, your randomness to be random. But this is more of a concerning answer. Well, I mean, we already know what that's. This is more of a concerning answer. Your variations are going to be random to an extent, but you're not looking for straight up chaos theory. Like, we're not in that level of stats. We're here basic intro to stats level stats. We are not going to look at pendulums or whatever.
Yeah. And most of your data will have some sort of pattern. You just want to make sure that that pattern isn't being biased by how you're picking your data points.
Exactly. Which leaves us one last answer. I was really scared that was about to be read, honestly. I was so afraid that was the wrong answer. Anyways, next question.
Ooh, math. Mutually exclusive.
I will give a second to calculate this real quick. Just a moment, though, because this isn't too bad.
Although my advice for stuff like this is to draw out a Venn diagram, because I do find they're pretty helpful.
That's fair. That's fair. Ooh, this is an interesting one. Okay, yeah. I think that should be enough time. What do you think?
I think that should be fine.
Yeah. Okay.
What is this, AP Calc?
Hey, we can make it AP Calc. So, dare I say it, I have a feeling it's not going to be the 0.3 that's already been established up here. You know, theoretically. But the rest of these are viable answers. You can get to the 0.12 by multiplying the two numbers. You can get to the 0.1 by subtracting, and you get to the 0.7 by adding. So how do we differentiate what we're looking for in either case? It can be either A or B. What I think is one of the more important parts about this is either is going to usually be the most likely thing to happen, because you have more opportunity for it occurring. It's most likely going to be one of the bigger values. Doing or some of the exclusive ones that are like, in this specific situation, it's like, it can be either of these, but not the or.
A or if B or stuff like that.
Exactly.
Lots of conditions.
The more words you put in, the more math you have to do in this class. But that's kind of how I remember the case of either. Is usually either's are going to be bigger probabilities. When you multiply, which I believe is the case of and, correct me if I'm wrong, you multiply if it's and.
Yes.
Awesome. Glad I don't.
Assuming they're independent, of course.
Yes, assuming that they are independent. Correct. And then in the case of 0.1, I don't know if is that it's
I
part
don't think
of
that's a
the
thing.
I think it's
I
a
think
step to figuring out or, but I don't think it's the only thing.
I think that would be if there is like an overlap between
Yeah.
A and B and you wanted to find like A but not B or something like that. But that doesn't count in this case because we were told that A and B are mutually exclusive or that they never happen at the same time.
Exactly.
I
Perfect.
know like heads and tails are mutually exclusive.
What if it lands on the side?
That's still not heads or tails. They're still mutually exclusive. They can't still be both.
Well, maybe I think it's both if it's on its side.
Oh, and by the way, your teacher might do the U thing, like A U B or A
The
upside
AU
down
thing.
U. I don't even know what to call it, but my teacher taught me that U, like right side up, is for union, so you're adding them, and the upside down one looks like an N, so N is an as in and A-N-D. So upside down is
Oh,
and, right side up is or/union.
interesting. I didn't even know that one. Wow.
Yeah, because I think that is the terminology they use on the AP
It
test.
is. It is.
Yeah. So you do need to know which is which.
Did you say the upside down or like the N?
Yeah, it
This
looks like an
big one?
N.
What'd you say that one was?
And
Correct. Sorry. My brain was I was looking at a Venn diagram as you were saying that. I was like, is that or is that and? Uh my brain is not in it today fully. Oh, okay, okay. Ooh. All right, now we're getting there. If the
Ooh.
if the probability of event A is occurring is 0.2 and the probability of event B occurring is 0.15, what is the probability of both event A and event B occurring if they are independent? Not mutually exclusive.
I mean, it'd be impossible for this to happen if they were mutually exclusive, because then there would be no A and B.
Well, maybe it was a trick question. I am taking a moment to do some math on my own, actually, to make sure I do not.
Although, in your benefit, on the AP stats exam, the whole thing I think is calculator allowed, so
It
you don't
is.
have to do much actual math.
I do believe the whole exam is calculator.
Yes.
Hmm.
Just remember that ands tend to be smaller and ors tend to be bigger. And they also tend to differ from the original probability, so.
There we go. Got my answer.
Okay.
Should I do we have any guess? Ooh, wait, do we have
Any guesses?
We have a guess at the top left first, but then a wait maybe not. You wanna would you like to explain where your head's going at with this question? Because there are a lot of ways to tackle this, and I actually threw myself off at first too.
For me, I just did and equals multiplication or equals addition, so I multiplied the two.
That's
Which is
too.
most of what you need to know for the test.
Yeah. Well, no, you cannot say that. Don't
Okay,
tell
for
me
this part of the test, like the probability section.
Okay. Yeah, guys, the only thing you have to know is multiplication and
Yeah, you
addition
don't
for the
need to know
entire
any
exam.
z-test or t-test stuff.
Forget the t-tests.
Yeah, forget them. No
T-
chi-squared for you.
Oh, God. Bleach Boy, that's exactly correct.
Yep.
Perfecto. Next question. Oh,
Oh, we covered this a little earlier, I
we
think.
did cover this a little earlier. This is a way to put it.
Mm.
Ugh.
Mm.
Trying to process what I'm looking at.
Lots of letters, lots of numbers.
Lots of arrows. Okay, yeah. So, do you want to explain this one again? Do you want me to take this one? Whatever you prefer?
Yeah, I can re-explain it. So basically, a geometric random variable is a function where you go until you get your first success, and then you're telling me the probability of the third or the fourth or the fifth trial being your first success. So to do that, you're going to have one success and everything else has to be a failure. And we're assuming that P is the probability of a success. So here we want one factor of P, or one factor of success. So everything here has that factor except the top left. And then you want everything else to be a failure. So assuming K is the number of trials, K minus 1 would be the number of failures, because you would have, again, one success, everything else is failures. So you want the 1 minus P, which is the probability of failure, to the K to the negative K minus 1 power. Yeah, so the bottom right.
Yes. Times the probability of success.
Yeah, times the probability of success.
Bada bing, bada boom. What would happen if we did K plus 1 instead?
You would introduce more failures that didn't exist, I guess, into your problem.
Introducing more failures than you even ran number of trials, which little concerning, theoretically. Perfect. Next question. Ooh. Which of the following statements about mutually exclusive events is true? I can tell you, the thing most important about being mutually exclusive is the fact that there is in fact zero interaction. So guess what I'm about to say? This one's wrong. Here, I'll prove it. Oh, I didn't.
You did prove it.
I didn't think it would show the correct answer.
We might as well go ahead with the correct answer then.
Yeah, I basically said the correct answer. They can't occur simultaneously. That's like definitionally mutually exclusive, cannot occur in the same time.
Yeah, you'll notice here, though, that they're not necessarily independent events and they can affect each other.
Yes.
So, for example, in a deck of cards, you can't draw a red card or a black card at the very same time. But if you draw a red card and don't replace it, you do change the probability of drawing a black card. So they are dependent.
Yes. Good additional explanation. Next question. I've learned a lesson. How does increasing the sample size affect the standard deviation of a sampling distribution? Woo!
Okay, I'll give you a hint here, and it's going to not be the standard deviation becomes 0, because increasing the size doesn't mean everything becomes identical.
Yeah, like, fun fact, just saying, not how that works.
Yeah, you can pick as many things as you want, but it won't make them all the same.
Dang it, that was my whole plan. I was gonna add 1 to every trial I did. God. Also, a fun fact about increasing the sample size. This is a very broad statement, which is kind of a hint for you guys. Saying, how does increasing the sample size impact the standard deviation? How does throwing more dots in impact the dot? What are you typing? Sounds like a typewriter.
Isn't that loud?
It's that loud.
Wow.
Here. Oh.
I think you turned your video off.
Did I? I did.
Now you were pretending to be Jessica for a second.
What do you mean? I am just. I saw Jessica and I thought she joined the stream. Anyways, what was I? Where was I at?
You were throwing more darts at the dartboard, I think.
Yes, throwing more darts at the dartboard. However, I'm verifying my answer real quick because I'm now... Okay, yes, I was right. You're throwing more darts at the dartboard, meaning you have more spaces taken up. By putting more darts in, assuming you do in fact have a trend, a noticeable trend, which I think is fair to assume in this case, you're just going to be getting more darts in the places that you haven't already hit, closer to that line, which should mean, theoretically, oh, well, guys, I can't teach y'all anymore. Sorry. I messed that up. Whoops.
Wait, let's read the explanation.
Yes, agreed. Let's read the explanation, friends. Increasing the sample size does not directly affect the standard deviation of a sampling distribution. The standard deviation of the sampling distribution is determined by the variability of the population and not the sample size itself. Other options are incorrect because I do not accurately describe the
Maybe submit a complaint, because they should say the standard deviation of the population. Of the sampling distribution, you are correct, because on the AP Stats formula sheet, the bigger N is, the smaller the standard deviation.
Yes, that's what I was.
Yeah,
thinking.
you're correct. I'm like, am I getting my vocabulary wrong here? But they are stating that like the general standard deviation of the actual population doesn't change, which is true because you're all pulling from the same population, but the standard deviation of all of your samples will change and decrease as you get more samples, as they'll be closer to the real thing.
There we go. Factual error? I think that's factual error. Bada bing, bada boom. Doing public service for the full account.
Yeah, when we're told we're wrong, it's a factual error.
It's not our fault if we're wrong. I thought I just butchered that and you didn't tell me.
No, because I thought that was the right answer.
I'm pretty sure it is. I'm like 90%.
Yeah, they were like, yeah, I think they worded that one badly.
Yeah, probably.
Yeah, because sampling distribution, I think, is the wrong word there. Okay, moving on.
Yes, sorry, I hit the button. Yeah, sorry. If x and y are two independent random variables and z equals x plus y, what is the mean of z? That is a question. Thinking this through myself. It's okay to take time to think things through. Also, I haven't done this in 3 years, in my defense.
Yeah, so maybe you guys are smarter than us.
I mean, that's very possible. Is there anything coming to mind for you? Because I'm trying to think through how you would solve this.
I'm pretty sure that it's just the sum of the means of x and y. Because, like, if I do, like, yeah, I don't think it's all that complicated. Because if you just, like, sum up two sets, then, like,
that's
eventually, yeah, the mean should just be the mean of the original sets added.
That I was stuck between that and like cannot be determined, and I was like, I cannot figure. Yes, that's a very good point. If you are adding two data sets, no, you know what it is? It's because it keeps saying random variables, so I think of individual numbers, not sets.
Yeah.
Anyways, so if you are adding two sets, the average of those two sets is just going to be the product or the sum. The sum of the two.
Not the product.
Not the product. Product is a very different thing.
Yeah, I think they use random variables because that implies that like certain values of the variables can have different frequencies, which is not really as obvious with the word set, but the word set is more intuitive. Like,
yeah, agreed. Awesome. So if the graph of a discrete random variable is right-skewed, what does it indicate? If something is skewed, theoretically, something's skewed, it's probably not normal.
Yeah. Bell-shaped is perfectly symmetrical.
Yes, bell shapes are like the ideal.
It's the favored child of the AP statistics world.
My favorite child.
I mean, it's the only child we talk about most of the time.
No, we're talking about our bastard child right now. Right and left skewed are over there, I guess. And there's like the...
Yeah, and then we talk about the conditions that we need to transform that into the favored child.
What's the double one? Oh my god, why am I forgetting this? The one that's here. There's a very
I think I know what you're talking about, but I don't know if there's like a name for it.
There is. There absolutely is. And maybe someone in the chat's willing to help out. It's this bastard.
I don't know, double peaked.
That's what I called it.
Yeah, I don't think any question like actually asked about that unless they're like, can you guess where the mean is inside this thing? But pretty much any one of like the z-test, t-test and stuff will like force you to make some sort of normal distribution to work it out.
Or will be a normal distribution. Yeah. Either one. Anyways, yes, that being said, probably not this one. This is true.
I think that's what you are talking about, though.
Maybe. You might be right.
Yeah, the M.
Oh, groups of values. Yeah,
yeah, that's the M.
Yeah. Anyways, so are the values concentrated on the left or the right side is the real question. And with this, it's very weird. I never liked it. Fun fact, if you're right skewed, you're going to have your values on the left.
Yep.
So the way I remembered this, and feel free to judge me if you will. Right skewed. If it had a tail on the right, things are not supposed to have tails. So it's skewed up. Skewed right. The skewed up part is on the right. It's a play on words of I'm calling the graph screwed up.
Okay, I get it.
I'm calling it screwed up, fun fact.
Yeah. Okay, so how our teacher made us remember it is that you're skiing. So it's when it's right skewed, it's easier to ski to the right because it's a smaller slope. And then if it's left skewed, you ski to the left.
That's a more reasonable way of remembering it, I think. I think that's a better. Listen to her reason, not mine. Mine is
skewed up.
Everything up there. Anyways, what is which of the following is an example of a continuous random variable?
As opposed to discrete, I'm assuming.
I believe so. I believe.
Yeah. That's the only thing that makes sense.
Okay. I don't even know where to start with this one because I know the answer. I'm just trying to find the best way to explain how to get to that answer.
So if it's continuous, it basically means you can have fractions involved. Mm-hmm. You can have percentages.
You can.
So for example, the bottom left is incorrect because you can't have like 3.5 students in the classroom unless you're in a horror movie.
Or, yeah, probably just a horror movie. I don't know. Maybe Steve's walking in late, and like at the moment they count, he's only like halfway through the door, so he's only like in class.
That's a very interesting way to think about things.
Well, I'm sorry. Have you not noticed that I'm a little strange in my ways of remembering stats? Have you not recognized this? Anyways, y'all are getting unhinged, Elias. Usually slideshows, I'm scripted to an extent. They're just loose. I'm off my leash.
Yeah, they were like, do whatever you want. And we're like, are you sure about that?
Are you sure you want us doing what we want? Because we're a little silly. We're a little silly here at Fiveable. Anyways, continuing off of that. You cannot have a fraction of a number of heads that appear when you flip a coin 3 times. And don't say on the edge. That's my joke.
Yeah, in the middle of it, they just chop the coin in half with a katana.
Yeah, like actually there just happened to be an invisible knife right where I flipped it. And the penny landed so perfectly that I just cut it in half. This is typical. Don't worry about it. Anyways, the number of cars passing through an intersection in a given hour, unless you want to start getting into arguments about different kinds of cars not being real cars, which we're not getting into, you're not going to get a partial. Height of a person, I feel like, is theoretically arguable, but like, no, because you can have fractions of inches. Like, you just don't usually say it that way. You don't usually, unless you're short like I am. I will go, oh yeah, I'm 5'5.5". I'm not even 5'5.5". I'm like 5'4.9". It's a little. I'm a short
Yeah,
king.
it's kind of like what little kids do with age. I'm like 9 years and like 4 months and 3/4 of a week.
Oh God.
Like
Oh my
very
God.
old, you get it?
I'm older than the other ones, I promise. Oh God. That should be an example on the ooh.
Ooh.
I'm gonna be honest. I'm trying to remember this part. The Bleach Boy, you just missed me saying that. You're so right. Agreed. You just missed me making that example. Actually, you like you must have gotten back right after.
Yes, he was referencing himself.
I was referencing myself, unfortunately. Anyways, conditional probability. Rearranging. May I be honest for a moment? We didn't rearrange this formula. So I can either check Google or you can take this one for me.
I'm looking at it.
Oh,
I'm
okay.
pretty sure it's not the general addition rule or the independent addition rule, though.
I don't think it would be addition because you're working with division.
Yeah, I'm
So,
like 99% sure there is no addition involved in this.
yes.
So it's either the independent multiplication rule or the general multiplication rule. And
Is this
wait, let me like try to figure this out. So
is this
P8
the
and
product
B.
rule? Because I know that that's a thing, but I've never heard it called the general or the independent multiplication.
Yeah. They worded some of these questions very strangely.
Oh, okay. Bleach Boy has a guess of the bottom left.
Okay.
We're gonna try it out. Your guess is better than ours right now. Hey,
Yeah.
all right.
Yay!
All right. So yeah. Fun fact though, just as like a general advice for the AP exam, if you're
Oh,
having
that's how they wanted to reword it. There, okay.
wait.
Yeah, so if you multiply both sides by PA, you get
Yeah.
PA times PB given A equals PA and B, which is the general multiplication rule because it gives you the PB given A. There you go.
I've never heard it called that.
Yeah, me neither.
It was the product rule for me.
Well, no, that was AP Calc for me.
No, there's a separate rule in AP Calc. There are separate product rules. What is this? I don't know. I like math. There's a reason I'm teaching it to y'all. God, I hate math. Just for clarification, you can like and hate something at the same time, I promise. Ooh.
Like chemistry gives you like 3 different names for every single thing in existence. Why?
Don't remind me. You forget I helped teach it. Anyway,
Okay. Shape
back
of
on
the
topic.
probability distribution of a geometric random variable.
So this is more of a trying to think of the best way to say this. Small thing, a little test taking strategy. Bell-shaped is already symmetric. Symmetric's just a broader way to say, like, is an umbrella that also covers bell-shaped. So I can guarantee that it's not going to be symmetric without being bell curve.
Yeah.
As for geometric random variable, I'm trying to get a good graph up. Random variable.
Well, if you think about it, like the higher the number is for a geometric random variable, the more things you're multiplying together.
There
right?
we go. Yes.
So
correct.
the probability is going to get smaller and smaller and smaller.
You verbally explained it better than I was going to be able to visually show. Yes, exactly.
Oh, yeah, there it is.
It's more likely to occur earlier on, and the longer it takes, it's like when you start flipping a coin and you're waiting for it to hit tails finally, and you start flipping it. At first, you're like, okay, whatever, normal coin flipping strats. But then after a little bit, it starts getting weird. And suddenly your 627 flips in, and you still haven't gotten to tails. And you check the other side of the coin. And the whole time there's been no head or tails. It has been only heads, and no one told you.
Either that or you're playing with a weighted coin.
Either that, yeah, one of the two.
Someone's gambling and trying to get you to lose money.
Someone would allow me, yes. Anyways, and remember what I said about skewed graphs. If the tail is to the right, it's skewed up to the right.
Okay, or you ski to the right. Why did I do that? That's wrong. Ignore that.
This is
Okay.
just straight up incorrect.
Yeah, just submit. Factual error. I think they're thinking about binomial because binomial should be bell-shaped. But this is not bell-shaped. This is very definitively skewed right.
Yeah. Ignore this. Also, by the way, just as like a general point for you guys, I know there have been a couple that we've been like, that's not right. This is a new platform that we're like actively developing. So some of the questions are a little off. If you're ever working with this program and you're like, hey, I just checked on Google and I'm pretty sure this is wrong, put in a thumbs down. Tell us, boo, you stink. You stink at your questions, and here's why. And we'll go, you're so right. We do stink at our questions. We'll fix it. We'll stink slightly less with our questions. Oh my God. Okay. We ready?
Oh, there's ST should mean standard deviation,
Yes.
I think.
Yes.
Yeah.
If the standard deviation of x and y is equal to the square root of standard deviation of x squared plus the standard deviation of y squared, what kind of variables are x and y? Oh my lord.
Yeah, I'd probably rule out continuous and discrete, right?
Yes, I would as well, I believe.
There's really no way to tell. You could be using fractional numbers or you could be using just a bunch of whole numbers and the math would be the same.
Yes, absolutely. Now when it comes down to independent and dependence, I want to say, and I'm not certain about this, I believe, bless you. I thought you were laughing at first. Sorry, I would have said
No, I was moving my chair.
Checking. I want to say that this is for independent. The Bleach Boy, come correct me if I'm wrong, please.
Yeah.
I do believe that this is for independent, though, because in the cases of dependent, there's too much variance that could be going on outside for there to be a consistent formula, I believe. I'm not.
Yeah, I feel like the dependent formula would be a lot more complicated than just
Agreed.
basically adding them.
I have a broken foot, but it's fine. Power of logic, people.
Wow.
Power of
And
logic.
also, if you look on the formula sheet, it is in fact that formula, and on any problem on the formula sheet, you're already assuming that you're independently sampling, so it kind of has to be independent.
Stop being smart and looking at the formula sheet.
Well, they give you the formula sheet on the test, and
Very
like
good point.
you'll
Absolutely.
have to use it.
Agreed.
Very
In all
important.
actuality, please use your formula sheet. I'm just so happy I managed to like brute force my way through that problem.
And as a trick, you can even use your formula sheet on the multiple choice questions.
Honestly,
because they don't exactly take it away from you.
Yeah, I mean, honestly, just use it. It's nice sometimes. In order for the you're so right. I didn't even think about that part. The Bleach Boy made a really good point. In order to use the variance formula when adding or subtracting distributions, the two random variables have to be independent from one another. Completely forgot about that point. Went right over me. I just brute forced my way through that. Anyways, what is the probability of an event occurring if all outcomes in the sample space are equally likely to happen? Ooh, and the answer choices are long.
A lot of answer choices.
Long answer choices. Of an event occurring if all outcomes in the same space Same sample space. Okay. So I think what's happening here is we have a sample space. And there's a indescript number of events. And we can say that that is X events, I believe.
No, we're saying here, like, if you're rolling a die twice, what is the likelihood of the rolls adding up to 12? Well, where adding up to 12 is an event, and there are multiple outcomes that would, or maybe just one outcome that would work in this case.
Yeah, I think with 12,
They add up to 7.
So, with these answer choices in mind, let me know if I need to zoom in again, actually, because I realized I zoomed back out. What stands out as things we need to eliminate?
I'm pretty sure you're not going to be adding or subtracting.
Bada bing, bada boom. No minusing. No, there's a multiplied. No, ignore these.
Yeah, ignore the top 2.
That's supposed to have a space.
It's okay. You're gonna judge them?
I'm considering it. Anyways, so the number of outcomes in the event divided by the total number of outcomes in the sample space, or multiplied by the total number of outcomes in the sample space. My guess, personally, would lean to divided by, and I might be incorrect here, theoretically, but
You're right.
what?
I think you're right.
I think I'm right too.
Yeah.
I think. In the case of multiplying it, you're kind of going to get somewhat of a nonsense answer that's going to be way too large to be an actual probability, is what my thought here is. Because you're multiplying it by the total number of outcomes.
Yeah, and I'm assuming that you're going to have at least whole numbers, because a number is hopefully countable, and probabilities go from 0 to 1.
Yes. So, bada bing, bada boom. Hooray. Oh.
Ooh. I think it's not PEMDAS.
I think it's PEMDAS. Oh gosh. Y'all were using mnemonic devices? Were you using mnemonic devices?
Yeah, I think I recognize which one it's supposed to be, but I can't actually remember what they stand for.
I'm sure it'll explain it.
Yeah. Yeah, I know it's the top right, because the first one has to be binary and then independent, and then I got a clue for the other 2.
Oh, I see. Yep. Okay. Number and same
Oh,
probability.
same probability, yeah.
That makes sense. All right.
There you go.
Checks out. Oh.
Ooh,
yeah!
look at that. Yay!
We did it, guys. We made it. Oh.
It only took us 3 minutes per question.
Yeah!
Yeah. Go faster than this on your actual test.
Oh, God. You don't have that kind of time on the actual exam.
How much time do you get per question?
Oh, let's see. In the multiple choice section?
Yeah.
Stats. Choice question. Amount. So there's 40 multiple choice. Oh, wow. A lot more than I remembered. 40 multiple choice in 90 minutes.
So you get like, yeah, 2
minutes.
That's not too bad, I guess.
It's not. We stayed fairly,
Yeah.
considering we had to explain everything.
Yeah, we did do a lot of explaining.
And a lot of giggling.
Yeah.
It's what we do here at the Fiveable headquarters. Another set, different units. Bleeps boy, you have any preference? I'm gonna put my hat on. Got my little Russian hat.
Okay.
All right, no preference.
Mm-hmm. Maybe you want to do a different unit so we get some other problems in?
Yeah, let's throw in let's do a nice little bit of unit 3. Nice little bit of that.
Collecting data.
Yes. This one is slightly more my forte. Slightly. To make sure that the results of an experiment remain unbiased, it is important to bias, no bueno. We don't want bias in our experiments. So, of the options given, manipulate the levels of
Wow.
manipulate the levels of the explanatory variables. Use a placebo group as the as the
I think
only
you've given up on experiment there. It's just an observation at that point.
measure the response variables before giving treatments, and randomly assign treatments to experimental units. In this case, we don't want people to necessarily be influenced by giving the treatment to some individuals and not others. Or we also don't want the experimentees to know what they're getting necessarily. We want it to be blind theoretically and be randomly assigning it, which is why the answer is very obviously manipulating the levels of the explanatory variable, and
Okay,
definitely
now.
not the only one that makes any sense in this context. Please know that I was trying to point to that being the correct answer. That wasn't a genuine guess on my end.
Yeah, I'll also add that sometimes you do measure the response variables before giving treatments in
Yeah.
order to establish a baseline. But in that case, that would be more acting as your placebo group. And
Yes.
it's not really talking about bias, it's talking about trying to see like the actual change caused by the experiment.
Agreed.
Bias basically means that you may accidentally find results because you assign things to certain people that already have different conditions, and this can be avoided by randomly assigning treatments.
Perfect. Yeah. Okay. Do you mind if I grab a drink very quickly?
Go ahead, I can read this one.
Yeah, I'm literally just going to the other side of my dorm real quick.
So, the outcomes that are measured after a treatment in an experiment are called. So, we have response variables, explanatory variables, experimental units, and control groups. So it's probably going to be a variable. So I would say it is not going to be the experimental units, which I'm assuming are either the people or the objects or animals involved. And it's not going to be control groups because those are not outcomes. Those are just people or animals or objects involved. So your outcomes are going to be measured by one of the two response or explanatory variables.
Hey, Bleach.
Oh, okay. Well, thank you for coming to Bleach Boy. I hope
Yes.
that helped you on your test.
Take care. We know we're a little silly goofy, but hey,
Yes.
take some of the info with you.
Thank
Have a
you.
great night. Good luck. Have a good test.
Yes. Get some sleep.
Please. Lord knows we all need it. Anyways,
Okay.
where are we at in the explanation?
Okay, so we're choosing between the top two for our outcomes that are measured.
Oh, are we asking for my input now?
Yeah.
Sorry. So, the outcomes that are measured after a treatment, one could say that one is, after being given a treatment. If I'm being given a treatment for my broken foot, we probably, theoretically, want a positive response as a product of said treatment.
Wow. And then explanatory variables are what's explaining what's going to happen. So they're what you change yourself.
For
Why they
example,
don't call it independent and dependent, I've got no idea, but they don't.
they don't.
They mean the same thing, though.
Just call it independent and dependent. I think they do most of the time on the exam. I think just
Yeah.
sometimes they pull out those words.
Mm-hmm.
Make sure y'all know it. Is there anyone actually watching right now? It says two, but I think that might just be Jessica.
There's one person on Fiveable and one person on Twitch. So
Yeah.
it might just be Jessica on both platforms.
Because
I don't know if there's any way to tell who's watching us.
I don't think there is.
Well, maybe I could like find the YouTube. Like, let me see if that's a thing.
I don't think it'll let you see the viewers though, unless they've commented.
Oh, that's true. Yeah, this isn't Crowdcast. Crowdcast tells us.
Ooh.
And we can spy on everyone in Crowdcast. Okay. Which bias occurs when part of a population has a lower chance of being included in a sample?
Oh, which bias occurs? I was like, I kept reading as which bias is avoided, and I was like,
Hmm. I don't know.
yeah. Ooh, okay. What? Okay, so my guess is that it is talking about undercoverage.
Me
Would
too.
wouldn't all of those technically be a certain demographic of people are less likely to respond?
I think they mean included in a sample, not likeliness to respond.
Oh, like being included by
Like
chance.
being even considered.
Okay, yeah,
Yeah.
okay, yeah, that makes more sense.
Yeah, like the example they always gave us is that if you're calling for your poll at like I don't know 10 a.m. At people's like I don't know landlines at their houses or whatever, then like people at work will not be answering you, and you won't get anyone at work.
Yeah, yeah.
I don't know. Do people still have landlines? Is that a thing?
Okay, my house tangent. My house had one as a kid, and it
Mhm.
worked, but I accidentally made too many calls out thinking that it didn't work, and they ended up getting rid of it.
Okay.
Like, I just thought it was like it wasn't plugged in, and I kept hearing like little noises, but I was like, "Oh, it's just because it's not actually working." No,
Mhm.
I was sending random ass phone calls on our landline. Poor people. Anyways,
Anyways.
ooh, what is the haha funny number? Funny number. Anyway, what is the goal of randomization? You look confused. I can't tell if you're confused by what funny number I'm referring to or just that I'm
No,
saying.
I'm aware. I'm
Okay,
just trying
good.
to read it because again, I'm blind.
Oh, here. Let me
Yeah.
there
They
we go.
should make like an automatic like thing so you can increase the font size on these.
I agreed, honestly. Or at least like a high contrast mode.
Yeah.
Anyways,
Yeah,
what
make it more accessible, Fiveable.
please.
Yeah, maybe we should put that in the Slack.
Maybe.
Okay, later.
Oh no, we're down
Okay.
to one viewer. We have
Oh,
one viewer, boys.
wow.
Anyways,
Okay, someone on Twitch.
hi Twitch person. That's probably Jessica. Maybe not Jessica. What is the goal of randomization? To simplify, randomizing things does not make things more simple. Fun fact. It just makes it
More
sillier.
complicated.
Yeah, more
Yeah, if I
complicated.
wanted easy, I'd just grab like the 10 people nearest to me for forget randomizing things.
Yeah, you want to be in my survey, by the way? My very random survey. Anyways, to introduce controlled variation in the experimental units. Fun fact, guys. That's like the like yes, variation is part of random. Controlled is not.
Yeah, if it's random, it's theoretically not controllable.
Yeah, theoretically, it's just crazy.
Kind of the definition of the word.
And I find the bottom right one weird. To ensure that the treatment groups are similar on all variables except for the treatment itself.
No, I think that one's right. Yeah, because the goal of randomization is that you
I
get
think it's to
groups
increase
that
the
are
statistical
mostly
power.
similar.
I think it's supposed to be increase the statistical power of the survey.
I don't even remember what power is. Isn't that like something they did
Like
with type 2? Like type 2 errors?
I don't. Oh, is it referring to that kind of power? I assumed it
I
meant like
don't know. What even is
statistical
power?
I thought it meant like viability.
I don't think so because isn't wait, let me look up statistical power.
Well, it could
I'm
very
pretty sure it was like related to type 2 errors.
Oh shoot. Okay. Yep. You're right. You're right. I concede.
Yeah, it's like the opposite of a type 2 error. It's like the likelihood of having a actual like good positive
I
besides
thought
like false
that wasn't a
positive.
misunderstanding of what power is. I just misunderstood what form of the word power that they were using.
Oh, I see.
Like that was more of a grammatical thing for me than it
Mhm.
was. Not that I really understood type 2 power or 1 power or anything like that. Anyway, we're gonna ignore that part. Ooh, okay.
Ooh.
A researcher wants to study the impact of exercise on blood pressure. They select every 10th participant from a list of patients visiting a clinic. What type of sampling method is the researcher using? Cluster implies a group, like a
Yeah.
close together. So one can
Like you like an example of a cluster is if you're like gonna survey like school children, so you randomly pick a school and then survey all of the kids within that school.
and assume that that one school is a
Yeah.
viable representation of
Yeah,
all.
viably random
Yes.
representation, yeah.
Simple random sampling.
That's
That's
just as random as possible.
yeah, I was about to say that is just random as possible, right? I didn't
name
want to be
out of
wrong.
hat random.
I'm checking one. Stratified.
Yeah, stratified random sampling is if you like take a couple people from every school.
Yes, that's what I thought.
Yeah.
I wanted to make sure I was not lying. And then systematic random sampling, creating a system every
Yeah.
10th. Ergo, bada bing, bada boom. Thank God you're here, because I think half of the things I'd be saying, people would just be like, what is he going on about? What is he saying?
Wow, a census.
Oh my God. A
Very
government agency? Which one?
the, the IRS.
Oh, great. The IRS wants to know the average income of households in the country. They require every person living in the country to complete a survey with the information necessary.
Yeah,
What?
it's your W-2, guys.
Yeah. Okay. So, fun fact, guys. If everyone's obligated to do it, it's no longer random. It's just obligated.
It's just everyone.
It's just everyone. The IRS, if one thing is certain in life, it's death and tax. That's two things. If two things are certain in life, it's death and taxes. And Elias being unhinged. The only
That's
one
three
that,
things.
the only one that doesn't directly say random, that is
Or sampling, actually.
oh no, it does say sampling. The only one that doesn't say random that isn't the correct answer here is cluster sampling.
Mm-hmm.
Cluster sampling is still a form of random sampling.
Mm-hmm.
So
Yeah, sampling implies that you're taking the smaller group, and census is just you're sampling the entire population.
you gotta do the thing. You have to.
You don't have to do any tests if you're taking a census. You just have to do the basic variable math because
Yeah.
it's already all of your information right there.
Censuses are censi, plural of census. Censuses.
Okay.
I don't like that.
Yeah, I'm pretty sure only the government has the resources to do that though, and only for stuff like taxes.
I don't know. You haven't met my buddy Jeff.
Unless you've taken a census of like all the pandas in existence, because there's only a couple hundred of them or something.
God. Aww. This is an apes discussion. I don't want to think about the pandas dying. I could do a census about all the nuclear bombs because I'm
not sure they'd give you the information.
Think there's only a few hundred of those. Fun fact, guys, if I ever got to write a DBQ, y'all would know it's me because it would be the most unhinged thing you've ever seen. Anyway, a researcher wants to estimate the proportion of adults in a city who support a proposed policy change by the local government. What is up with okay, they divide the city into different neighborhoods and randomly select households within each neighborhood to survey. What type of sampling method is the researcher utilizing?
Well, it's not simple.
Oh, yes, correct. You're so right about that. I'm silly. My brain completely misread part of the question for a second there. Yes, correct. Not simple. They're not making it very simple. Dare I say it, it's not systematic either.
Yeah, they're not going like every 10th household on the block will be sampled.
Yeah. They're going, neighborhood, And you know what that's indicative of?
Gerrymandering. Zoning.
I think zoning is more accurate than gerrymandering in this case, but sure. Also, stratification. Why were we trusted to run this together?
I don't know, but I learned that my roommate's district is in 4 congressional districts. So
The what?
yeah, she's in 3 different towns, like her address, and in 4 different congressional districts.
How does her mail address work?
I don't know.
Like, I get the weirdness of living in a township because those are like weird and like you're in a city, but you're also in a town. What? 3 cities?
Something like that.
Oh my god. Local governments, get your stuff together. Which following statement accurately describes a population context of a statistical study?
So what's a population, basically?
Oh, really?
Yeah.
Oh, that's a weird way of asking that question.
I think it's supposed to say accurately describes the population in the context of a statistical study.
Oh, should I?
You know what? Just download all of this.
Don't tempt me.
This would be very ironic if it was like an SAT writing question.
Oh, what?
This would be very ironic if it was like an SAT writing or an English question.
I think we should use these as SAT English examples.
What is wrong in this sentence?
Actually, you know what? Scratch that. We should make the people who help read over the questions sit down, and we're going to say it's an SAT English exam. But actually, just examples of questions that were written poorly and are not accurate.
And they give him options to different ways to fix the question.
We have an FRQ section, and it's just fix all of the multiple choice, please.
What did you do wrong here? Okay, next question.
Yes, I suppose. Ooh. Which of the following is a potential consequence of using convenience sampling in data selection? Convenience sampling. It's convenient. How does that bring in bias? Oh, shoot. How does that bring in issues? Ignore that I just said that word. Guys, fun fact, it's the bias. It's the word I didn't think about not using. Yeah, if you're using convenience, you're probably going to the people that are around you, your friends, your coworkers, your family. Fun fact, all those people are probably going to have things in common that probably do not apply to every outside person. Therefore, you're going to have some bias. It's not going to be very representative of the general public. etc., etc. Bada bing, bada boom. Oh. Which of the following biases can lead to incorrect conclusions about the safety and effectiveness of medication?
It's not random sampling.
It's not, yeah, random sampling's good. Convenient, honestly, I feel like any sort of bias can cause issue. But I feel like any of these can. Anyways, self-selection. Ooh, okay.
You might guess voluntary response, but I'm not totally sure with this one.
I'm not sure if it's voluntary or self-selection.
Yeah, it can be convenience. Because my thoughts with voluntary response is like, if you didn't have a problem, you're not likely to say anything. But if you had a problem, you're likely to complain, which overinflates the danger of the medication.
Agreed.
That's why they have to put all those disclaimers on the ads that like this can cause like kidney failure or whatever. Because like anyone who took the medication and experienced that during the testing, even if it wasn't from the medication, like they have to say that it was a statistical conclusion.
Yeah. The only reason I'm kind of wondering if it's self-selection is if because the people who would choose to partake in this that
like placebo effect?
No. If the people who are willing to put that risk on their bodies are probably people who are healthy enough to do so and are comfortable doing so.
Or maybe they're just like sick and desperate enough to take something.
Not usually, especially not in low. Okay, now that I'm thinking about it, I'm starting to get a little bit too sociological with this, and this is just an AP Stats question.
Yeah.
Oh.
Let me see. What does it say?
I need to stop walking on my foot. Oh my god, why do you make it tiny?
I don't know.
Here, 1 sec.
Oh, there we go. That's vague. I feel like there should be a better explanation. That goes for all three of them, right? They need like more issues with these questions. That is such a vague answer.
Guys, actually, the stream is no longer us talking about the SA or AP Stats. It's actually just us correcting every question we go by. Anyway, now you're going to tell us what bias means? Now? Which bias occurs when the way a question is asked influences the response given? Wow, it definitely cannot be the answer that says wording. That's not likely at all. Oh, whoa, would you look at that? I do not feel the need to explain that one. I don't know if that's...
Yeah, it's basically when you're creating a bunch of leading questions on a survey.
Yeah.
Like, make people feel guilty for answering the opposite thing that you're trying to find.
You're not supposed to do that? That's not what you're supposed to do?
Well, if you want positive results instead of accurate results, then I guess go ahead.
That's what the CIA told me to do. God. Anyways. Why do I keep doing that? Every time. Okay. You're conducting a survey to gather information about the voting preferences of adults in a country. Country. Which of the following methods is most likely to result in a representative sample? I really thought census was going to be on here again. I was about to
Yeah, that would have worked.
Random sampling, convenience sampling, quota sampling, or cluster sampling. Quota sampling?
Yeah, I'm looking that up right now.
Okay, well, that's non-random, so fun fact, no.
I've never really heard of quota sampling on the test.
Either. Wait, what? I would say it's not cluster, right? I'm stuck between cluster and random in this case.
I mean, you might as well go with random, because random seems pretty good.
All right.
I mean, cluster could technically work because it is considered a random type of sampling, but simple random is even more random, I guess.
Stratified would be the best if you're trying to gather information about voting preferences broadly. I want to downvote this, but this technically isn't wrong. I just disagree.
Yeah. I mean, I guess cluster would be bad because if you like went to a super Democratic area or super Republican area and like sampled everyone there, then it wouldn't exactly be reflective of the overall country.
That's fair. That's a good point.
Yeah.
Anyway,
because opinions can be like considered geographical in some cases.
Yeah, no, definitely. That's a good point. Okay. In an experiment, the individuals that are assigned treatments are called...
They're the variables here.
You're so right, actually. Yeah, the things that are being experimented on are in fact...
for people, like, they prefer you use subjects instead of experimental units.
I don't.
They're the
Refer to
same
me
thing.
as a unit and a unit only. My pronouns are unit. There's a slash between UN and IT. Anyway, nope. I'm cutting myself off. I'm not allowed to say anyways anymore. No more. What does random assignment allow researchers to conclude about observed changes?
I mean, there's only one that kind of makes sense.
Yeah,
here,
I don't
right?
even know what to say. I was like trying to figure out what to even.
Yeah. I mean, the whole purpose of this is that you're trying to find something that's statistically significant. If
Yeah.
it's not, then like, why bother?
Dang. Sorry, I was looking at another message in the Slack.
Oh.
When should we end?
I think like at 8. I don't know. Is it Jessica? Jessica, if it's you, can you drop something into the chat?
I think we're allowed because we've been stagnant.
Mm-hmm. That's if we have like 0 people.
I think we are technically at 0. I think practice 5
Me?
is just here. I'm gonna.
Are we like 100% certain? Because like if someone's like actually watching us, I mean, 1, we're kind of sorry, and 2, we don't want to just quit on you.
Okay, Jessica's not here, so is someone else watching or? Hey, Twitch person, you want to let us know if you're a human being or not?
No, it's just a random bot watching us.
Well, I don't. Maybe it's Steven. I don't know. Can't even find Steven on the list. I'm like 99% sure Steven's in the PQ list. Am I going insane?
I wish this was like Crowdcast and we could spy on everyone involved.
No, yeah, that's like the best part.
Yeah.
View on Twitch.
I mean, we only have 20 minutes left, so we might as well just go ahead.
No, I'm so obsessed with figuring out who the one person is, though.
What if they want to remain a mystery?
Well, they're not allowed. Oh, I figured it out.
What?
Twitch counts yourself as a viewer.
That's it?
Yeah.
Okay. So it's just us?
It's just us.
Okay.
I'm fine.
How sad.
It's been just us since Bleach Boy left. Just I think a little sadder. We're talking to the void.
And then some recommended channel has like, I don't know, 20,000 people playing Fortnite.
Maybe we need to have a 5able stream where it's just us playing Fortnite, but on our like, I assume not really good computers. Like this is a MacBook. This ain't running Fortnite. Oh god. I think that would be silly. We could
5able hosts, good at APs, terrible at gaming.
Hey, speak for yourself. I win Jackbox 50% of the time.
Statistical likelihood of that and all.
Maybe I'm just an outlier. Do we want to end and like discuss?
Yeah, I think we can end and like put stuff in the Slack.